Hello students, so today we will continue with our chapter chemical reactions and equations. I had given you homework to learn symbols, formulae of radicals and their valencies. I hope you have done it. Another way of learning the valencies, I will show you how to do it using periodic table which has been given in the textbook. This was in the syllabus, but now they have omitted it for this academic year, but in 11th we will have to study in detail. Now you will see in this periodic table that on the top 1 to 18 are written. You just go towards downwards of column A from lithium. Lithium, you can see here, lithium, sodium, potassium, rubidium, cesium. All these are called alkali metals and their valency is 1. Also hydrogen valency is 1, so it is placed on top of it. So learn this, that these are in group 1, their valency is 1. Then beryllium, magnesium, calcium, strontium, barium. You learn so much that their valency is 2. So these are called alkaline earth metal. Then we'll come to 3A. Boron, aluminium, gallium. You just learn these 3. Valency is 3. Carbon, silicon, germanium. Valencies are 4. Then nitrogen, phosphorus, arsenic. You learn this. Antimony also, bismuth. They are in 5. So means their valency is 8 minus 5 means 3. So their valency is 3 negative. And here the valencies for metals are positive. Positive means they will give electron, so they will become positive ion. Here 5A will become negative because they have got 5 electrons, so they will accept 3 electrons, so they will get minus 3 valency. So these are their negative valencies. Then similarly in 6A valency is 2 because they have got 6 electrons in the autonomous orbit, so they will take 2, so they will become minus 2. And last, I had given you last time, fluorine, chlorine, bromine, iodide. If you learn up to so much also, it is fine. Their valency is 1 and they are called halogen. Then helium, neon, argon, krypton, xenon, radon. They are inert gases. They don't react. They are also called noble gases. So this periodic table would be given in the chemistry textbook. Have a look and you can learn in this manner also. But what I gave you last time, I will, because now we have to learn variable valencies which I have not shown you, so I am showing you now. So this, last time I did not tell you to learn. Now you see how to learn this. You learn copper, mercury. Copper and mercury have got variable valency 1 and 2. So, and iron has got variable 2 and 3. So learn in this manner: copper, mercury, variable valency is 1 and 2, iron valency is 2 and 3. Then you know costly metals are silver, gold, platinum. So silver is compared to cheapest and platinum is costlier. So silver valency is 1 and 2, gold is 1 and 3 and platinum is 2 and 4. So learn these 3 as a group: silver 1 and 2, gold 1 and 3, platinum 2 and 4. Then another 3 group is of tin, lead and manganese. Valencies are 2 and 4. So learn this variable. Carbon and silicon we have just learned that the valencies are 4. Carbon is a non-metal, whereas silicon is a metalloid. Is it alright? You can see, okay. So you can see how both are in group 4. But this comes under non-metal and this comes under metalloid. And that you can forget. You learn this variable valencies also. Now let me see how much you have learned the formulae and valencies. whenever we learn any language, first we learn its alphabets. So learning the symbol is learning the alphabets. Then we learn how to write the words. So now we will be learning how to write the words in chemistry. Like suppose you are taught ferric oxide. Whenever in the end there is IC, whenever in the end there is IC, so it means it has got higher valency. Iron valency is 2 and 3. So ferric oxide means valency is 3. So ferric oxide, so we write Fe for iron and O for oxide. Then ferric valency is 3, so write 3 below it. Oxide valency is 2, write 2 below it, and then to cross multiply. So formula will become Fe2O3. So this is the formula for ferric oxide. Is it alright? As such, nowadays they write in a easier way. They write iron and in bracket they will write 3, Roman 3. So means iron having valency 3, and then they will write oxide. So if they write in this manner, it becomes simpler. Now ferrous, if there is OUS at the end, it means valency is lower one. And nowadays how they will write? So they will write iron, iron, and in bracket they will write 2. So this is the another way of writing. So ferrous sulfate valency is 2. So ferrous sulfate SO4, 2 and 2 cross multiply, then 2 will go like a common. So it will be only FeSO4. 2 has got cut as it is common. Aluminium sulfate, Al aluminium, sulfate SO4, write valencies below. Aluminium valency is 3, sulfate valency is 2, cross multiply, you will get Al2SO4 3. Then aluminium phosphate, aluminium Al, phosphate PO4, write the valency is 3, cross multiply, 3 will be common, so answer would be only AlPO4. Now phosphoric acid, any acid means it starts with H, so HPO4, hydrogen valency 1, phosphate 3, cross multiply, so H3PO4. Potassium chlorate, potassium K, chlorate ClO3, 1 both valencies, cross multiply, so you will get KClO3. So in this manner we have to write the words, and so you can write the words in case you know the symbols. So you learn whatever I had given you last time, the valencies, formulae for radicals, then you can write the words. Is it alright? Now after knowing how to write the words, now we will learn how to write the sentences. So now that is called writing chemical equation. So now we'll go to how to write a chemical equation and how to balance it. Now chemical equation means, like suppose you are telling sodium reacts with water, forms sodium hydroxide and hydrogen gas. So this is in words. So now this we should write in a scientific way using equation, so that many information can be conveyed by writing only one equation. So we will write the equation. I will explain you. On the left hand side, the substances which take part, suppose A reacts with B, so A plus B, it is forming C and D. C plus D, suppose plus E, it can be anything. Then this is called a chemical equation. Above the arrow and below we write the condition. In case A and B have to be heated, we make a triangle here. So means they require heating. Sometimes we write here the temperature value, pressure value of the other catalyst. So all that information we write in this arrow, above and below. Is it alright? So then, as you know, we have studied in the previous classes law of conservation of mass. Mass does not change. As I told you last time, in chemical equation, so therefore the atoms which are taking part, suppose 10 hydrogen atoms are taking part, then this A may, some hydrogen atom may get removed from A, but then it will get added to another group B. So if A is losing some hydrogen atoms, some other product which is forming, that is gaining. So total number of hydrogen atoms has to be 10 in case A is having 10 hydrogen and B does not have hydrogen. If A has 10 hydrogen atoms, B has 2 hydrogen atoms. So total hydrogen atoms taking part in chemical reaction is 12. So in C plus D plus E, total number of hydrogen atoms have to be 12. So if now suppose 3 or 4 elements are taking part in the chemical reaction, all elements on the left hand side, means on the reactants and product, have to be same. This is called balancing the equation. So we should write for some numbers here, that how many molecules of A and how much. Suppose if I say 4A, what does 4A mean? 4A means 4 molecules of A. Suppose molecule of A is water, H2O. So when I write 4 water, it means I have got 8 atoms of hydrogen and 4 atoms of oxygen that are taking part in the chemical reaction. So this number tells us how many molecules I should take of this substance. The number of molecules taking part of A and B need not be same. Is it all right? So finding these numbers is called balancing the chemical equation. Now there are various methods of balancing these equations. I will teach you one foolproof method and simple method, that is called algebraic method using equations. Is it all right? So we'll proceed further. So this is the first example. He says sodium metal. So you should know how to write sodium. So I've written Na, sodium. Reacts with water. So I've written the formula of water. Then it is forming sodium hydroxide. So I've written NaOH, sodium hydroxide. Sodium valency 1, hydroxide valency 1. And hydrogen gases are always by having 2 atoms, 1 molecule. So I will write H2. So Na plus water gives NaOH plus hydrogen. I have not written how many molecules are taking part and how many molecules are getting formed. So this is called skeletal equation. So this, sometimes in exam they will give in the word form, or they may give you this skeletal equation and tell you to do balance. Now you learn the steps of how to do the balancing. First step is you write number of molecules of all this in the form of A, B, C, D, E. Like sodium, so I have written A. Water, B. Sodium hydroxide, C. Hydrogen, D. So this is the first step. Now we should count the number of atoms. So which atoms are taking part? Sodium, hydrogen, oxygen. So I have written here sodium of sodium atoms, number of hydrogen atoms, number of oxygen atoms. Then in reactants, how many I have got? In products, how I am having. So now let us concentrate on sodium atom. So in my reactant, I have got Na means Na1. So A, so means A atoms are taking part. So in reactants I have written A. Now in product I have got here. Here the molecules are C. So sodium atom in the product is C. This does not have sodium atom. Now we will go to hydrogen atoms. Hydrogen atoms are here. H2 means 2 atoms of hydrogen but B molecule. So this gets multiplied by this. So B into 2 is 2B. So written reactant 2B. In product it is 1 hydrogen here. So 1 hydrogen means C into 1 is C and 2 into D is 2D. So in product hydrogen atoms are C plus 2D. Then oxygen atom. Here O means O1. So B into 1 is B. So in reactant I have got B. In product O is 1, so C, and here does not no oxygen, so it will be only C. So this is the second step. Is it all right? So this step you should learn, that how to write. Whatever atoms are taking part, you make a column, and reactants and product you write how many are there. Then we'll say let A be 1, this number A. I can also say let B be 1. I can also say So any one of the variable I can put equal to 1 or equal to any convenient number with Zupin. But normally 1 is the most easiest number. And you should choose A equal to 1. It will be, I will explain to you again when I complete this so that you will understand. If A is 1, then my C would be 1. A is equal to C. So I have written here. Then I will get C equal to 1. Now B is equal to C. So if C is 1, B is also 1. So I have got the answer of 3. I assumed A equal to 1, C equal to 1, B equal to 1. Now which equation is left? Which I have to find out now? D. So I don't know D here. Here B is equal to C. I have used C. A is 1, so C is 1. C is 1, so B is 1. Now 2 into 1 is 2. So this is 2. And C is how much? C is also 1. So bring 1 here. So 2 minus 1 will give me 1. So 1 equal to 2D. So D is half. So this is simple algebra. Now knowing this value, you substitute the values A, B, C, D here. So you will get Na, A is 1, so I need not write. B water, B is 1, I need not write. C is 1, I need not write. But D is half, I will write half. But we never write fractions in the molecule. So to multiply this full equation by 2. So I'll get 2 sodium plus 2 water gives 2 NaOH plus hydrogen. 2 multiply half is hydrogen. Only 1. So this equation is balanced. We can check. How many are sodium reactants? 2. Products 2. How many are hydrogen here? 4. Here 2 into 1H2 plus H22. So 4. Oxygen 2. Oxygen 2 into 1, 2. So means my equation is balanced. This is how balancing has to be done. Now the important thing which I was telling you, that which variable we should assume 1. So try to see that by assuming certain variable I should get maximum answers easily. So here I could see A is 1, C is 1, C is 1, B is 1. So this is the correct way to assume. You could have assumed C also 1, then C is 1, A is 1, C is 1, B is 1. But in certain things you have to see. Or one thumb rule is whichever variable is occurring maximum number of times, you assume that. Or you can just orally try, or by practice you will easily come to know how the things have to be done. Okay, now we'll go second example, then things will become more clear. But gradually examples will become slightly tough. Heated iron, so I write iron, Fe. So you should know the symbol, language. With steam, steam means water, forms iron 2,3. When I say iron 2,3 means there are 2 molecules are joining. When iron is 2, it will be FeO, because both are 2, so 2 is common. When it is 3, it would be Fe3O2. Sorry, Fe2O. See, FeO, and then next will be Fe2O3. Because its valency is 3, so 3 will be here, it valency to cross multiply. Now if I add Fe plus Fe2, I will get Fe3. O and O3, I will get O4. So when we say iron 2,3 oxide, means one molecule is made up of one of with 2 valency and one with 3 valency. So it is Fe3O4. This you can learn also. Plus hydrogen. Now after writing skeletal equation, so now we will, second step is to write A, B, C, D. So I have written A, B, C, D. Now after writing A, B, C, D, so now what are the atoms taking part? Iron, hydrogen, oxygen. So now again we will try to see iron, reactant is only A. Product, where is iron? Iron is here. And this is Fe3. So C into 3 is 3C. Then hydrogen. Hydrogen is where? Here is hydrogen. So 2B. And here where is the hydrogen? Hydrogen is here, H2. Okay, H2, and this is D. So 2 into D is 2D. So this is 2D. So 2B equal to 2D implies B equal to D. Okay, now we go to oxygen. Oxygen is B because this is 1. And here oxygen would be 4 into C, 4C. So B equal to 4C. Now this step is over. Now we should think that which we should assume. So this is C is here, C is here. If I assume C, I will come to know A, I will come to know B. So I have taken that C be equal to 1. If C is 1, then A would be 3. So A is 3. If C is 1, B would be 4. So B is 4. Now to get D, B is equal to D. So D is also 4. Now I know all the numbers. You write the number place of ABCD, you get the answer. So this is the final equation. This is the final equation. Is it alright? Now we'll go next one. This is quite simple. He says methane burns. This will be learning in the second term that what is methane. Methane is CH4. Oxygen, you know, when it burns, everything is burnt, we are burning in air, so oxygen take part. So O2 will give carbon dioxide and water. So this is my skeletal equation. So I will write A, B, C, D. Then I will say reactants, carbon atoms. How many are there? A. Then here right hand side carbons are C. So A is equal to C. Then hydrogen atoms. How many are here hydrogen atom? 4 into A. 4A. How many are in products? 2 into D. 2D. So now 4 and 2 I can cancel 2, so I will get 2A equal to D. Then oxygen atoms. Now let us see oxygen atoms. We are having this oxygen, this. So 2 into B is 2B. And right hand side 2C and here also D. This is 1 to D. So 2C plus 2D. So this is my third equation. So 4 unknowns means 3 equations. Now we will assume 1. So again I have assumed A as 1. Because A is here, A is here. So from here I will get C, here I will get D. So A is 1, C is 1. A is 1, so this is 4A. This is 2D. So I will get D equal to 2. So I have got this answer. C equal to. So now we will go to next sum. Next sum reads that copper reacts with concentrated nitric acid. So copper is Cu, nitric acid HNO3, forming copper nitrate. Copper valence is 2, nitrate is 1, copper nitrate plus water plus NO2. So this is skeleton form. So I have written off A with A, B, C, D, step 1. This I am calling equation 1. Now let us count all the elements in reactants and products. So elements are copper, hydrogen, nitrogen, oxygen. Now copper in left hand side is A and right hand side is C. So A equal to C. Hydrogen atoms, left hand side is B into 1 and here it is D into 2. So B equal to 2D. Then nitrogen atoms, left hand side is B, right hand side nitrogen atoms are 2. This is 2 and this is C. So 2C. And nitrogen also coming here, so 2C plus E. Then oxygen atoms, 3 into B, 3B, and in right hand side, 3 into 2. So nitrate, there are 2 nitrates to 1 copper. So 3 into 2, 6. So 6 nitrate to 1 molecule to C molecule, 6C plus D. Okay, because this is 1. 1 into D is 1. 2 into E is 2E. So I have got these four equations. Now I am assuming B equal to 1 because B is here, B is here, B is here. So when I take B as 1, I will get 2D equal to 1. So D equal to half. From this equation, listen carefully, B is equal to 1. So I will get 1 equal to 2C plus E. So I written 2C plus E equal to 1. So then I am writing E equal to 1 minus 2C. So I can replace E in terms of C. So this is very important because it is simple. We are solving it simultaneously like. Okay. So I have written E equal to 1 minus 2C. Because from equation 4, I know the value of B. How much is B? 1. So this becomes 3. And D is half. So when 3 minus half, I will get 5 upon 2. So I will get 5 upon 2 equal to 6E plus 2E. Substitute the value of E in terms of C as 1 minus 2C. You will solve, you will get C equal to quarter. So then you will get all the values or variables. This is simple algebra. Then you substitute, we will get this as the equation. Quarter copper plus nitric acid forms 1 upon 4 copper nitrate, half water plus half NO2. LCM of this all fractions is 4. So I will multiply the equation by 4. I will get my balanced equation. Copper plus 4 nitric acid gives copper nitrate plus 2 water plus 2 NO2. You can check in exam whether I am right. Copper 1, hydrogen 4, hydrogen 2 to the 4. Then nitrogen is how much? Nitrogen is also 4. So 2 nitrogen here and 2 nitrogen here, 4. Then oxygen is 12, 3 4 the 12. Here 6 and 6 is there, we are counting oxygen, and 2 oxygen is here, 8, and 4 oxygen is here, 12. So my equation is fully balanced. In this manner, you can check in exam. Now next sum is quite simple. Magnesium nitride. You should know to write magnesium nitride. Valency of magnesium is 2, nitride is 3. If I cross multiply, I will get Mg 3 and 2 plus water. Magnesium hydroxide. Magnesium valency 2, hydroxide 1. So MgOH2 plus ammonia NH3. So now I have written only A, B, C, D. Now I have to count magnesium atoms, nitrogen atoms, hydrogen atoms and oxygen atoms. So if you count in reactants, magnesium is 3 here. Magnesium is 3 into A, 3A. And in product, magnesium is C because here it is 1. Then nitrogen atoms, N2, so 2 nitrogen. In product, nitrogen is coming here, so D. So 2A equal to D. Then hydrogen atoms, 2 into B, 2B. In products, hydrogen atoms are coming 2 into C, 2C, and 3 into D, 3D. Then oxygen atoms, where are oxygen atoms? B into 1, B. And here it is 2 into C, 2C. Okay, so these are the how we have counted. Now we'll assume A as 1 because A is here, A is here. So when you assume A as 1, so you'll get C as 3. Once C is 3, then you'll get the value of B. B is 2C, so B would be 6. So B would be 6 and D is 2A. A is 1, so D is 2. So now I know the value of all. I can write the equation by substituting the value of A, B, C, D in this equation. So you will get Mg3 and 2 plus 6 water gives 3 magnesium hydroxide plus 2 ammonia. As I told you in previous sum, you can count. Magnesium is 3, here 3 magnesium. Nitrogen is 2, so nitrogen is 2. Hydrogen is 6 2s are 12, here 3 2s are 6 hydrogen and 6 hydrogen here. So all are balanced. Okay, so in this manner you have to solve the numericals. Now we have to go to next sum, last sum of the day. Manganese dioxide. So you should know to write di means 2. So manganese and 2 oxygen. So MnO2 I have written here. This is a skeleton equation. And hydrochloric acid HCl. Manganese chloride. So MnCl2 here written manganese dichloride. So chloride are 2. So manganese valency 2, chloride 1. Here value of manganese is 4 because MnO2 oxygen is 2, so this is 4, so 2 is taken common. So 2 has come here. So I have written now A, B, C, D, E. So this my equation gets formed. Now, so I am counting all the atoms. First manganese. Manganese is how much? A. In products, manganese is coming here, so C. Chloride atoms, B, and here chloride are coming 2C and 2D. Hydrogen atoms, B. In product, hydrogen is coming here, 2E. And then in oxygen atoms, 2A. And here it is coming, oxygen atom is only in this place, in this molecule. So E into 1E. So now I am assuming B as 1 because B is here, B is here. Okay. So if I take B as 1, then I will get E as half. See, B is 1, then E is 1 upon this, B is 2E. So E would be, B is 1, so from here I will get value of E as 1 upon 2. So E is 1 upon 2. Then A is coming here, A is C. How much is C? And you know the value of, from here you will get 2A is equal to E. So E I got as half, so A would be 1 upon 4. So using this equation, you can get the value of A. And E equal to half you got using this equation. Because B is 1, so E is half. Now E is half, so A is 1 upon 4. Now A equal to C, so C is also 1 upon 4. Is it alright? So now I have to get D. D is coming here. You put the value of B and C, you get the value of D. B is 1, C is 1 upon 4, so 2 into 1 upon 4, I have written 2 upon 4. So you get the value of D. Now knowing the value of A, B, C, D, I will substitute A, B, C, D in this equation 1. I will get this answer. Then I will multiply by 4, which is the LCM of all the fractions. You will get the final balanced equation. So this is how numericals or balancing of the equations have to be done. So I have explained to you algebraic method, which is foolproof method. Any equation can be solved by this method. I hope you have understood. But for you to do yourself independently, first you try to solve all the 6 examples yourself. Then solve all the balancing questions given in your NCERT book and any reference book. If there are any difficulties, you can ask me. Thank you.